Hey guys, 9-2 part 1, reciprocal function family. All right, we have 3 different examples that we're looking at today. Hopefully you'll find it not too bad, but we are just graphing reciprocal functions. We have 3, as I've already said once, 3 different examples we're looking at. All right, so the first one, or before we get started in the first one, let's introduce ourselves to the reciprocal functions. A reciprocal function is any function that has a variable in the denominator. So f of x equals 1 over x, but of course x can't equal 0 because then that would be an undefined function. The general form of the reciprocal function is right here, y equals a over x minus h plus k. A is going to be your shrink and stretch, and if it's negative, it reflects it across the x-axis. The h is your movement right and left, k is your movement up and down, right? So we're going to see a little bit of everything with that, but not so much in this example. We're going to see the h and k part in part 2. We're only going to see the part of a today. All right, so let's see our first example. Okay, so the textbook example, you have sketch a graph of y equals 6 over x, and of course x can't equal 0. Now, at first glance, seeing this vast amount of values in a t-chart, we'll call this a t-chart even though it's on its side, is a little bit intimidating. It seems a little bit too much, over the top. But looking at the graph, you see that we actually have 2 separate graphs, 2 separate branches for this one particular graph. So therefore, we do need more x values than we're used to. Typically, we can get away with 5 for any standard function. But in this case, I'm saying you need 4 to the left of the vertical asymptote and 4 to the right, because that gives you a good guideline. I don't want to say connect the dots because then some of you will connect the dots, but a guideline to draw your curves through, okay? All right, so let's go ahead and look at the one for your notes. Draw a graph of y equals 0.5 divided by x. So the very first thing that I'm going to do is create a t-chart. All right. Now I know that this can't be 0, so that means I need to have values less than 0 and I need to have values greater than 0. So I'm going to go with -3, -2, -1, and -1/2. Right, and this one might be a little bit tricky at the moment, because why in God's name would I pick a 1/2, right? Right, and then 1/2, 1, 2, 3. Fractions are not necessarily my best friend or my strongest suit, but they are worthy allies at times. All right, so let's plug these in, evaluating the equation for this value of x. 0.5 divided by -3 is going to give you -1/6, which was -0.17 approximately. 0.5 divided by -2 is -0.25. 0.5 divided by -1 is -0.5. 0.5 divided by -1/2 is -1. 1/2 divided by 1/2 is 1. 1/2 divided by 1 is 1/2, or 0.5. 0.5 divided by 2 is 0.25. 0.5 divided by 3 is 0.17. 0.16 repeating, so 0.17, good enough. All right, so now let's hold off for just a moment on plotting these points, and let's see if it makes a difference, right? And sometimes it does and sometimes it doesn't, but it's those cases when it does that really does kind of hit home as to why I picked those fractions, even though they are not necessarily my first initial go-to numbers. Right. All right, so right now I'm just sketching my coordinate plane, and bear with me because I'm doing this with the wireless slate, which is completely blind. I'm doing it freehand, which, you know, when I'm standing from the smartboard, I sometimes have struggles right there. All right, so we have -3 and then -0.17, which is going to be right about there. -2 and -0.25, right about there. -1, -0.5, and then we're holding off on the 1/2. 1 and 0.5, 2, 0.25, and 3.17. So see, there's not a lot of curvature going on there, and there's a little bit more here, but it could be just the way that I plotted that. But let's go ahead and put in the 1/2. So you have -1/2 and 1 and 1/2 and 1. So now that really does give you that, oh, okay, it's taking off right here, and it's then leveling out right there. And likewise, we're coming in close to that axis, and then we hit the y-axis and we go on down. And I'm sorry, that is such a sketchy sketch. All right, so this would be the graph of the 0.5 over x. Okay, all right, next example. We have graphing the reciprocal functions. Now, this is the one where we are doing things to the numerator, all right? So as your value increases with respect to the absolute value of the numerator, your graph is getting further and further and further. It's being pulled away from the origin. But if this number in the numerator was smaller than 1 but greater than 0, absolute value given, then it would actually get closer and closer and closer to the origin. So as it gets bigger, it moves further away. As it gets larger or smaller, it gets closer and closer. If you happen to have a negative in the numerator, it is going to reflect it across the x-axis. Typically, your reciprocal function is in the first and third quadrants, but if you have a negative a value, you reflect that and you have graphs, the branches in the second and fourth quadrants. All right, so now let's go ahead and take a look at doing the -2 over x. Now I did this one in class for you guys, and if you don't have me in class, this is the one I selected, or you weren't in class. We have y equals -2 over x. Okay, since there is no value being added to the x in the denominator, I am just going to stick with the -3, -2, -1, -1/2, +1/2, 1, 2, 3. Just because it makes it easy. I don't have to keep coming up with different numbers. And the thing is, it just cannot be 0. So I want numbers less than 0, and I want numbers greater than 0. So now putting these numbers into this equation, and the reason I picked this one is just because it has a negative in the numerator. We've already done this one, and we don't really need to do these. All right, and we're just doing it as an example. Okay, so the -2 over x. So putting this in, you have -2 over -3, so that's positive 2/3, which is approximately 0.7. -2 over -2 is 1. -2 over -1 is 2. -2 over -1/2 is 4. -2 over 1/2 is -4. -2 over 1 is -2. -2 over 2 is -1. And -2/3 is the same as -0.7. All right, so now let's go ahead and sketch this. All right, and I'm just adding the tick marks to my coordinate plane right now. All right, so now let's go ahead and graph these points. So we have -3, 0.7, -2, 1, -1, 2, and then 0.5, 4. 1/2, -4, 1, -2, -2, -1, and then 3.1 or 0.7. Boy, I can't speak right now. All right, now go ahead and draw your branches through those points. And there you have it. So now this is in quadrants 2 and 4 because we always start here. So 1, 2, 3, 4. All right, the final example that we have today is the real world connection. And this one is giving us a formula, and we are instructed to find one of the missing variables. All right, so it says the frequency f in hertz of a sound wave varies inversely with its wavelength w. The function f equals 343 divided by W models the relationship between F and W for a wave with a velocity of 343 meters per second. Find the wavelength of a sound wave with a frequency of 440 hertz. Okay, so if you think back to, I believe it was chapter 7, when we did the inverse functions, and in a standard equation, you would just switch your x and y variables and then solve for y. But given a formula, you don't do that because it gets really complicated, so we just solve for the variable. So since we're looking for the wavelength in this case, we're going to solve this equation for W. So let's go ahead and do that. So F equals 343 divided by W. Well, right now my W is in the denominator. That's no good. I need to get it by itself. So first things first, since it's down in that denominator, I want to get it out of there. So I'm going to multiply both sides by W. Cancels on the right, and I'm left with WF equals 343. I'm still solving this for W, so I need to divide both sides by F. And now we have the formula W, the wave, equals 343 divided by F, the frequency. We're given that the frequency is 440 hertz. So W equals 343 divided by 440. Well, this gives us 0.7795. So this is approximately 0.78. Now, technically, we were supposed to solve this graphically, but I feel in this case, algebraically is just as fine, if not easy or easier than graphically. But in keeping true with this lesson, I do want to show you how to do this graphically. So go to Desmos. I'm going to substitute in the Y for W and X for F, okay? So then that means Y equals 343 divided by X, and if my F is X, then over here the frequency is 440, so then F, or X in this case, has to equal 440. All right, well right now there's nothing on my screen, so you want to zoom out. Starting to see something. All right, there we go. Now we have both graphs, both lines visible within our view. So I'm going to keep zooming in here. And now click on it and you'll see the intersection. Hover over that intersection and what do you see? 440, 0.78. So when our frequency is at 440, our sound wave is at 0.78. Awesome, right? So totally up to you. I'm an algebraic person myself, but graphically, obviously, just as valid. However, on the test, you have to do it algebraically. All right? Okay, have a great day. Talk to you guys later.